Hello everybody, welcome to my channel. Today we have a very good problem for you guys, and we're talking about reverse integers. So this is a very good problem. So let's quickly see what the problem statement says, right? So it says, given a signed 32-bit integer x, right, return x with each digit reversed. If reversing x causes the value to go outside of the signed 32-bit integer range, which is this range, right, negative 30 to the power of 31 all the way up to 2 to the power of 31 minus 1, right? So then return 0. Okay. Assume the environment does not allow you to store 64-bit integers, okay, signed or unsigned. So very good problem statement, right? So they're telling us that we're given an integer, right? And it's a 32-bit integer, and we need to reverse it, right? So give an integer, reverse each digit, right? So it's kind of what they're saying pretty much, right? And since we're guaranteed 32-bit integer, right, when we reverse it, we need to make sure that if it goes out of bounds of a 32-bit, right, which is this range right here, guys, right, then return a 0, guys, right? If we, while we're reversing the digit, we go out of bounds, right, then we return 0, guys, right? So a very important thing to do. And this thing right there, a very good constraint that they're adding on us, right, to increase the complexity a little bit more, is to uh, assume that the environment does not allow you to store 64-bit integers, right? So signed or unsigned. So very good. Make sure you worry about that. So 123, guys. So we're given this input 123, and the output is 321. Okay. So you can see that this is a simple number, and then the reverse number is 321, right? Which is exactly what we have here, guys, right? So simple as that. And then we have a negative 123, and the reverse of that is negative 321, right? So make sure that we take into account the negative, right? So very important. And the last example is 120. You might be tempted to say 021, 021, right? The reverse, right? But that's not actually the case, guys, right? The case is just 21, guys, because we don't want leading 0, guys, right? So that's why that case is a little bit different. We need to make sure that we take that into account, okay? So now that we went through examples, how do we go ahead and solve this, guys? That's kind of what's important now, right? Sort of algorithm do we need? We could do this particular way. Maybe we can convert this into some kind of a string, and then reverse the string, and turn it back to a number and send it to the caller, right? That'll be good enough, right? But you know, some interviewer might not let you slide with that, which is not good, right? So how do we come up with a better solution, guys, right? Especially without having to need additional like their structures and things like that. How do we go ahead and solve this? I think we could be smarter than that. So how do we go ahead and solve it? So what I'm thinking is we've done problems in the past where we are able to process things, process numbers, right? And processing them digit by digit, right? And those kind of manipulations that we've done before, right? So if you haven't seen those kind of problems, probably link them somewhere here. You guys take a look, right? So that's something that you need to get familiar with to process things digit by digit, right? Things like that, right? So, but don't worry, I'm still going over details here, guys, right? So how do we solve these cases, right? You know, how do we reverse 123, guys, right? 123 can be reversed by processing one thing at a time, right? It's just we just like I was doing, right? So we would probably have another variable, right, that just gets it 3. Then we go to the next number. So because we need to traverse it from right to left, guys, right? Because we want the last digit to be the first one, right? And so on and so forth, right? So we're gonna do 3. We add it to a new number that we're guarding. Then we add 2, right? Then we add 1, right? Just like that, right? So how do we do that? It's gonna be very interesting, right? So how we're gonna do is every time we're going to get the last digit, right? So let's see. Let me show you how the algorithm is gonna look like. So to make it so this will be the num. Say it's go 1, 2, 3, and then the rev initially would be 0, right? And then each time we're processing, right, we would just do, so we have 123, then we would have rev would become 3, right? So every time as well, right, we're gonna multiply it by 10, right? So that we can so initially it's 0, so we multiply by 10, and then we add whatever digit that we extracted, right? So we've extracted, so now it will be 3, guys, right? And then we need to remove that digit from the number, right? Okay, so that we can process the other numbers, because we're always going to be getting the least significant digit every time, right? We've done problems similar to this type of concept, right? So I'll probably link it here so you guys could go check it out as well, right? So every time we get the least significant digit, and then we're at we have 2, right? So now how do we add it to the number, right? We just do we multiply whatever number that we have by 10, guys, right? So whatever the value red is at a particular point, right? It's gonna get updated, right? So now it's 3, so we're gonna multiply by 10, and then we're gonna add the least significant digit that we just extracted, right? Which is 2. So now the number becomes 32, guys, right? And then we can remove that as well, guys, right? Okay, so now we have 32, right? So now for the last digit, we just do we extract it, right? And then it's 1, and then we just put 1. We do the same concept, we just multiply by 10. So we can shift the numbers to the left, right? So we can have we have space to add the 1, right? Because the 1 is going to be the least significant digit. And then we do +1, and then now it becomes 321, guys, right? So how do we extract this, right? The last digit, right? We're going to do a modulus, right? To get the remainder of the division, right? We're going to mod 10 to get the last digit, right? You know what I'm saying? So that's how we're going to end up doing that, right? So very simple in terms of algorithm, right? To reverse the numbers, right? It's not going to cost us any space, which is a little bit more efficient than doing it the way that I was telling you guys earlier, right? So now, because of this constraint, right? The problem is going to give us, it's going to increase, the complexity is going to increase a little bit more, right? So how do we go ahead and solve this, right? So, but I'll show you guys, I'll go through the code, and then as we're doing it, we're going to go over those edge cases that we need to sort of worry about, right? So, but it's going to be very simple, right? So what we're going to have here is they have called the reverse num, right? So this is the reverse number. So we're going to do while the x is not equal to 0, right? So while there's still digits to be processed, right? We're going to get things one at a time. So last digit is equal to so whatever x is, mod modulus 10, guys, right? So we extract the last digit, right? And then what we're going to do is so reverse number, remember the formula that I mentioned, guys, it's going to be reverse times 10, right, plus the last digit that we just processed, guys, right? And then remember, so every time we're going to need to shrink the last digit, guys. I mean, the x, right, divided by 10. So now, so that's the example I was saying, guys, right? So it was 123, so we processed 3, right? We added 3 to our reverse number, right? We appended, right? So now we can remove 3, guys. So we can divide here, guys, right? So now let's worry about those edge cases that we were saying, right? So those overflows, right? So we're gonna overflow if the reverse number, right? So I'm going to do a check before I multiply by 10, right? Before I multiply by 10, right, I'm going to do a check, right? If I end up multiplying it by 10, right, would it overflow, right? That's the check I'll be doing here, guys, right? So integer that max value, right? So if it's greater than integer that max value divided by 10, right? Remember, this is the 10 that I'll be multiplying here, guys, right? That's the 10, right? So let me quickly get that real quick. So it makes sense to you guys, right? So this is the case. This is the case here, guys, right? So you say we get a reverse number, right? So this is the maximum value that can be, right? Maximum value, positive value that can be represented, right? So they say we have the case where we are reversing the numbers, right? And then we have something like that, for example, right? So when we're gonna be, so if we still have digits to be processed, right, we're gonna have to multiply this by 10, right? Which will just make this add a 0, right? If we multiply by 10, guys, right? If we multiply by 10, then it goes out of bounds, right? Which is bad, right? So that's where we end up gonna have to return 0, guys, right? So before because we don't want to multiply by 10 yet, right? Because so we do the check before we multiply by 10. That's what I'm trying to say, right? We do the check before that, right? So if this value, right, is greater than the maximum value that I have, right? Divided by 10, right? So divided by 10 removes the last digit, right? So if it's greater than that, guys, right? If it's greater than that, then we know obviously the columns will change accordingly, right? Okay, make sure it's very clear to you guys, just like okay. So now it obviously is greater, so it goes out of bounds, right? Because if we multiply by 10, right, then right. So that's what I'm trying to say. Hopefully, it makes sense. Watch this video over, so if it doesn't, right? So before multiply by 10, right, we check the max value divided by 10. Is it greater than it, right? Because if I end up multiplying by it, it will definitely become greater than this value, right? So that's why we return 0, guys, right? And then we're gonna do the same check, guys, right? But this time checking for the main value, right? So we don't want to go out of bounds on the main side as well, guys, right? The negative side as well, right? Which is very important, right? It's a range, which I'm illustrating here, guys. This is the range that we have here, guys, right? All right, so after that, we might be in good shape, right? I think most of the cases can be resolved with this edge cases. I mean, the test cases that are given, right? There's probably one more check that I need to do with you guys first, right? So you can see it works. I'll pass all the test cases as well, right? But there's one more thing, right? So let's say we end up with the case where we have, remember I said we have this number, right? So let's say it was this number, right? So obviously this is not greater than this, right? It's actually equal to it, right? And you might be saying, oh, can we just do equal then, right? No, God, it can't do that, right? Because we can represent a lot of numbers, right? With this number still, right? So if we end up adding 7, right? Anything 7 and under, right? Then we are still within range, right? But if we end up adding an 8, then we're gonna be in a bad shape, right? We're gonna go out of bounds because that's the maximum value that I can add, right? Right. So make sure it makes sense, right? So we have this number, right? And before we add number to it, right? It's not greater than this, right? But if I add any number greater than 7, right? Numbers are greater than 7, then we go out of bounds, right? So we're gonna have to do another check here, guys, right? Which is very important, right? Equally as important as the other those checks that I did here. So let me get some space for you guys. Try to hurry up. If the reverse number, right, equals to that number, okay? Okay, so it's equal to this number, right, which is this number here, right? We divided by 10, not worrying about the last digit, right? So if the reverse number is equal to that, right, and right, the last digit that I'm processing now, running out of space, should I zoom out a little bit? All right, so it's clear. Okay, the last digit is greater than 7, right? Then that's the case where we return 0, guys, right? And we're gonna do the same check here, guys, the same checks, but a little bit more different, right, to make more sense of the negative case. So obviously we're gonna need to check if that's a min value, right? Okay, and we know the min value is this, right? Make sure I copy it and paste it there as well, right? So we have so it's the minimum number that we can represent in 32-bit, right? So let's say now the number that we have is this, right? Okay, so obviously, out of bounds is going to depend on which last number we end up adding there, guys, right? Which is we're going to be adding it there, right? So we're checking what number it is, right? So if the last digit, right, is less than the last digit that's possible, right? So if it's less than -8, right? We're talking about -9, right? That's why if it's a -9, then that's bad, right? But if it's a -8, then I'm still within bounds, right? Right? So -9 is smaller than -8, right? So if it's -1, -2, we're still in good shape. We're still within range, guys, right? It would not hit that case, guys, right? So let's press run code, guys. See if we pass the test cases. Awesome. Let's press submit. Awesome, guys. We're able to pass all the test cases, guys, right? So this is a very good problem. The hardest part of this problem is those edge cases, making sure that we stay within the 64-bit that's the 32-bit that's allowed, right? We could easily use long and we would have not worried about those overflow cases and things like that, right? But they kind of increase the complexity a little bit more, but it's still fun, you know? So if you guys understood the thought process, you guys enjoyed this video, let me know that in the comment section. If you're new here, make sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.